Hey everyone. So in this last part of the video, we are going to talk about the lagging strand and how it is created in DNA replication. First of all, I need to point out that because this parent strand up here, the original DNA that had been unwound, was in the 3 to 5 direction going from the origin of replication towards your replication fork, that means that this other strand that is anti-parallel is going to be in the 5 to 3 direction. So going from the origin of replication, this strand is anti-parallel to this top strand. That's our parent strand. So in this case, our parent strand is running in the 5 to 3 direction. As a result of this, what happens is when we make the lagging strand, our lagging strand will be made in the 3 to 5 direction from the origin of replication towards the fork. And this presents a problem because the last carbon that's going to be available for us to attach to is carbon number 5. And DNA polymerase 3 can only add to the third OH group, or the OH group on that third carbon. So the lagging strand is going to be made slightly different than the leading strand. We're still going to use primase to lay down a primer. As you can see right here, I've got an RNA primer. And then what's going to happen is this primer is oriented just like the overall strand. But instead of starting here on the 5 and working towards the replication fork, DNA polymerase 3 is going to do something different. DNA polymerase 3 will start on the third carbon, that third OH group, the OH group of the third carbon over here, and then work backwards towards the origin of replication. Once it reaches the origin of replication, it's got nowhere else to go. So what we're going to do is we're going to lay down another primer further up ahead of the DNA, or further up ahead of the segment we just created. Lay down another primer. It is still 5 to 3. And then from here, DNA polymerase 3 can add nucleotides until it reaches the end of this primer that it started off with at the beginning. So now this segment is complete. To continue, we're going to add another primer further up the strand, and again, it is still 5 to 3, and then DNA polymerase 3 is going to start adding the nucleotides at this end and continue adding them until it reaches this primer that we had laid down previously. Each of these segments, because we have to stop, lay down a new primer, start again, and then stop, lay down a new primer, and then start again. This is called discontinuous replication. And every single one of these fragments or segments that we have created is called an Okazaki fragment. Okay, so the Okazaki fragment itself allows the DNA to be made in the 5 to 3 direction, so that DNA polymerase 3 has that third OH group on that third carbon to bind with. But once it reaches the end, once it reaches the origin of replication, what we're going to need to do is we're going to need to lay down another primer. So we've laid down this one. Now we're going to put this one and expand it. Once we reach this point right here, we're going to stop, lay down another primer further up ahead, and expand this one, and we're going to keep going that way on the lagging strand. So the lagging strand is made what we call discontinuously. Overall, we're still going in this direction. We are still going from 3 to 5, but we're doing that by adding Okazaki fragments, which are 5 to 3 individually. And we start here, then we lay the next one and expand. We're still going 5 to 3. Lay down the next one, expand. We're still going 5 to 3. Once we have started this process, we're going to go ahead and replace those primers. Once again, we're going to be using DNA polymerase 1 to replace the primers. They were RNA, now they're going to be made with DNA, and then all the segments will be glued together using the enzyme called ligase. The name and the process may seem like it's slower than the leading strand, but it is not. So the way you're going to identify the lagging strand is either by the presence of multiple primers, multiple Okazaki fragments, or another way is by looking at the new strand being made. If the new strand is being made in the 3 to 5 direction, then that is going to indicate that this was the lagging strand. So the lagging parent strand runs from 5 to 3, and the lagging strand is made overall 3 to 5. That's how you'll know it's the lagging strand. Another big clue is going to be the Okazaki fragments themselves. The Okazaki fragments will go from 5 to 3 because we need that 3' carbon for DNA polymerase 3.